Guys, Mr. Schwanenkamp. Today we are talking about graphing. So we're going to change gears a little bit. So far, we've talked about properties of graphs. Now we're going to talk about graphing functions. And there's a whole lot of things in here. Some of these you've done before, some of you haven't. It's just a matter of understanding the different setups. So a lot of information in this video. It's going to be fairly long, but a lot of necessary information. You got to understand a lot of this to do anything with graphs. So don't feel overwhelmed here. You got to work your way through it. There's some memorization. You can do it without memorization, but I like memorization the best. All right, absolute value. So we're going to graph these different functions. All right, so absolute value, you know what absolute value does? It makes everything positive. All right, so I'm going to make a little t-chart first. Let's plug in 0. If I plug in 0, I am going to get 0 because absolute value is 0 is 0. What happens if I plug in 1? Absolute value of 1 is 1. If I plug in 2, I'm going to get 2. Plug in 3, I'm going to get 3, and so on, and so on, and so on, and so on, and so on. But what if I went the other way? What if I had an x value of -1? If I put a -1 and I take the absolute value of it, it's going to get you a +1 answer. And if I do -2, it's going to get me +2. If I plug in -3, it's going to get me +3, and so on. So what ends up happening here is I get this shape. The graph of an absolute value function is going to be a V shape. I give it a nickname just that way we can understand it and I can talk about it a little bit more. But a V shape is an absolute value. It starts with a V. It's going to make a V, absolute value. The shortcut to making one is simply up 1, over 1, up 1, over 1. It's very simple to graph it. We will up and over, up and over, up and over, up and over, up and over. That's my V, absolute value. Next one is a quadratic. You've graphed a quadratic many times now. If I were to plug in 0, 0 squared is 0. If I were to plug in, again, I'm plugging into x squared. If I plug in 1, 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. Let's go to the negative side, -1. -1 squared is 1. -2 squared is a +4. -3 squared is a +9, and so on. Here is the shape that it makes. This shape should be pretty familiar with you. What is our nickname for that? That is a parabola. Again, if you took first semester with me, you know what the shortcut is. We are going up 1 over 1, make a dot. Up 1, 2, 3 over 1, make a dot. Go up 1, 2, 3, 4, 5 over 1, make a dot. And that's just a quick way of graphing it. A lot of this chapter is about doing this quickly. So that is why we're learning these shortcuts. But the shortcut is 1, 3, 5. Up 1 over 1. Up 3 over 1. And so on. That is our shortcut to this graph. 1, 3, 5. I didn't mean to erase it, but you get to see me do it again. All right, that's parabola. Cube, x cubed. So let's plug in some numbers. If I plug in 0, 0 cubed is 0, because 0 times 0 times 0. Plug in 1, 1 cubed is 1, 1 times 1 times 1. Plug in 2, 2 times 2 times 2, that would get me 8. If I plug in 3, I'm going to get 27 way off my graph. So if I just connect these dots over here, I know it's going to do something like that. And it looks kind of like a parabola, all right? But the other side, what happens when I plug in -1? Well, if I take -1 and I cube it, that is -1 times -1 times -1. If I multiplied those three things out, I would get -1. And if I did -2, I would get -8 because there's 3 minus signs. 3 minus signs is going to keep it negative. My graph is going to look like this. All right, so my nickname for this graph, and kind of silly, and I come up with a lot of silly names here, but this is a broken parabola. Okay, it's a broken parabola because normally a parabola would look like this. But that side right there has been broken downward and it's now below the line. So it's kind of like a parabola, but you break one of those arms and you put it downward. So that is my broken parabola. My shortcut for this one is I'm going up 1 over 1 and then up 1, 2, 3, 4, 5, 6, 7 over 1. So my pattern is 7. That is my shortcut pattern for a cubic graph. Square root, and this one's a little bit harder to see, but a square root graph, we're going to start off by plugging in 0. If I take the square root of 0, I get 0. What happens if I take the square root of 1? Well, the square root of 1 is 1. I don't really want to plug in 2, because if I plug in 2, then I got to figure out what the square root of 2 is, and I don't know that one. And I don't know what the square root of 3 is either. The next number I really want to mess with is 4, because I can take the square root of 4. The square root of 4 is 2. And then the only other one I'd really want to play with again is 9, because the square root of 9 is 3. It gives me this graph right there. Looks kind of like a parabola on its side and only half of it. All right. Well, what about negatives? Let's plug in -1. If I plug in -1, I'm going to take the square root of -1. That's imaginary. And the square root of -2 would be imaginary, and so on. So there is not going to be anything living in this world over here, because I can't take the square root of negatives. My graph is only going to go from 0 and to the right. All right, so my nickname for this graph, so this is a little bit different when I do it in my classroom, but in my classroom, I tell my kids, and I can't turn my video on right now or I would do it. I tell my kids to show me with their arms, what do these shapes look like? And so imagine a parabola, they hold up 2 arms. Well, for this one, I'm going to draw a picture. Oh, yeah. You're going to really check out my artwork here. Oh, yeah. Again, if my camera just worked, I would show it to you. But instead, oh my goodness, look how long my arm is. This is me drawing. Oh my gosh. Oh man, this is why they pay me the big bucks, to make pictures like that. That is what you would look like. See how my arm is making that square root graph? Oh yeah, it's making that square root graph. And if you look at that graph, imagine the song I'm a Little Teapot, Short and Stout. Here is my handle, and here is my spout. I refer to this as a teapot graph for no other reason than it helps me to remember it. It is a teapot graph in my brain. You do not need to remember that. If you tell anyone else in the world that it is called a teapot graph, they will laugh at you, because that's not a thing. But it is a teapot graph, at least to me. And that's how we set that thing up. So that's a teapot. What is my pattern here? I feel so embarrassed right now. I go up 1 over 1, up 1 over 3, up 1 over 5. So my pattern is 1, 3, 5 again, but I'm going up 1 over 1, up 3 over 1, up 5 over 1, and so on. So it's kind of the opposite of a parabola. Last one, cube root. So we're going to take numbers to cube root. So the cube root of x. If I plug in 0, I get 0. If I plug in 1, I get 1. I cannot cube root 2 or 3 or 4. The only other number I could cube root is 8, because the cube root of 8 would get me 2. It's going to get me this picture right here. Great. What about the negatives? Well, the cube root of -1 is -1, and the cube root of -8 is -2. I'm going to get that picture right there. And we could have kept going, but I'm trying to speed up the process. So there's my graph. What is the nickname to this graph? I call this an S curve. So it's not exactly an S, but you can see that S type of shape going on, even though it's not perfect. That's an S curve. Okay. Some refer to this. Yeah, that's fine. S curve. Shortcut. What's my shortcut? Up 1 over 1, up 7 over 1. My pattern is 1, 7. It's exactly like the cubic graph. It's just on its side. You can see how these two look similar. You can see how these two look similar. All right, hope those help. I'm glad I still got that picture. I think we need to bask in its glory. Yeah, zoom that guy in. Oh yeah, it looks even worse when you can see the pencil marks. Man, that's rough. All right, let's keep going. So on the back side here, we are just matching these things. And so we're just looking at what's the shape, what's it going to match with. My first one here, if I were to give that one a nickname, that is the parabola looking shape. So which one of these functions gives you a parabola? That would be x squared. And what's the pattern for parabola? It's up 1 over 1, and then up. Oh, here it is. That was weird. Up 1 over 1. So it's over 1, up 1, over 1, up 3. I don't know why I switched the wording, but that is the parabola shape. Okay, so it goes with that one right there. Sorry, that looked weird to me for a second. All right, next one. I've got this cubic graph, this little broken parabola, so you can see that it used to be a parabola, but it broke down. Which function is going to get you that? That would be an x cubed graph. And the pattern for that is over 1, up 1, and then over 1, up 7. It's going to get me that guy right there. Over 1, up 1, and then over 1, up 7. Boom, and then boom. That's going to get me my cubic graph. Next one, I got a big old V. Which one of these things is going to get you a V? Boom, absolute value. Absolute value gets you a V. And the pattern is very simply up 1 over 1, up 1 over 1, and so on. Here I've got a cubic graph on its side. So what's going to get me that one? That is a cube root graph. My cube root graph, the pattern is still going to be 1, 7, up 1 over 1, up 1 over 7. The last one here, I got a teapot graph. This little graph on its side. A teapot graph goes with a square root, and the pattern for that is 1, 3, 5 again. Hopefully those make some sense to you. It'll take some time, but in that next video, we'll kind of go through them again and graph them all together. So I hope that makes sense to you. I will continue in my next video.